In this lesson, we are going to find vertex, intercept, and graph of the given quadratic function f of x is equal to x squared plus 4x plus 6. Let's get started. The given function is f of x equal to x squared plus 4x plus 6. Now for this function, a is the coefficient of x squared, so a is equal to 1, b is equal to 4, which is coefficient of x, and c is equal to constant, that is plus 6. Now since vertex is equal to minus b over 2a 4ac minus b squared over 4a. So we are going to substitute the values of a, b, c in the formula. So this will be equal to minus 4 divided by 2 times 1, comma, and 4 times 1 times c is 6 minus 4 square divided by 4 times 1. So this will give us the value of x coordinate of the vertex and y coordinate of the vertex. X coordinate is minus 2 and this is 24 minus 16 divided by 4, and this is equal to minus 2 and 2 here, which are coordinates of the vertex. If we want to verify this, we can do verification as well. Let's do the verification. For vertex is equal to minus 2 and f of minus 2. So that is the other formula for finding the vertex. And here let's find out value of f at minus 2. This is equal to minus 2 square plus 4x means minus 2 plus 6. So this is equal to 4 minus 8 plus 6. Again, this is equal to 2. So we have verified that again vertex is equal to minus 2 f of minus 2, which is equal to minus 2 and 2. So we are done with vertex, and now we'll find x-intercept. For x-intercept, f of x is equal to 0. This means x squared plus 4x plus 6 is equal to 0. We can use quadratic formula to find two values of x. To find solution of this quadratic equation, it cannot be called quadratic function anymore, because when you set the value of quadratic function equal to 0, then the values of x which produce that value then that relation is called quadratic equation. To find solution of this quadratic equation, we have a is equal to 1, b is equal to 4 like before, and c is equal to 6, and we use quadratic formula x equal to minus b plus minus b square minus 4ac divided by 2a. So now when we substitute the values of a, b and c, this becomes minus 4 plus minus, and b square is 16, minus 4ac is 24 divided by 2a is equal to 2. So this will be equal to minus 4 plus minus negative 8 square root. As you can see, whenever negative is inside the square root, that is not a real number anymore. So obviously this is not a real number, which tells us that there are no x-intercepts. But if we want to find those complex numbers or imaginary numbers, we will complete the procedure like this: under root 8 iota, because iota is imaginary number equal to minus 1 under root, divided by 2, and this is equal to negative 4 plus minus 2 into under root 2 iota divided by 2. If we take 2 common in the numerator and divide it with this 2, we'll be left with minus 2 plus minus under root 2 iota. So these are imaginary values of the x-intercept. For finding y-intercept, put x equal to 0. And if that is the case, then y, which is in fact equal to f of x, is equal to 0 square plus 4 times 0 plus 6, means y is equal to 6. So the y-intercept is equal to 0, 6. And now at the end we need to find out the graph of this parabola. Here the a value is equal to 1, as we have seen for graph. That is number 4. Now let's find the graph. Find the graph, and for finding the graph, there is one way of getting the table of values and then plotting the points on the grid and joining those points with freehand curve. That will give you a parabola. But we have learned another method, and that method in fact is very easy if we know what is vertex. So we already know what is vertex. Vertex was equal to minus 2 and 2. Now the graph of changes in values of the graph of given function, changes in y values of the graph of given function are equal to a time 1, 3, 5, 7, because changes in the y values of the base graph are 1, 3, 5, 7. Every time we want to draw the graph, we simply calculate what is a and multiply it with changes in y value of the graph of base function y is equal to x square. So here, once we have a equal to 1, so this is exactly 1, 3, 5, 7. These will be changes in the y values starting from the vertex. So let's get started, and here if we draw the x-axis, let's say that these are x-axis, and let's say that these are the y-axis. If these are x-axis and y-axis, then where is the vertex? The vertex is at -2, 2. So if this is x-axis, this is x dash, this is y dash, and this is y. -2, 2 is right here. So this is vertex V, -2, 2. And we will be using these changes in the y values. So one step right, because a is positive, so this graph opens upward. Let's write that down as well. Since a is greater than 0, so the graph opens upward. And starting from here now, one step right and then one step up. So this is the point. And then one step right and 3 steps up. One step right, 1, 2, 3 steps up. 1, 2, and 3. And then one step right and 5 steps up. 1, 2, 3, 4, 5. So this is what we have. And similarly, we go one step left, one step up, one step left, 3 steps up, 1, 2, 3, and then one step left and 5 steps up. 1, 2, 3, 4, 5. Here we have points which we need to join in order to produce the graph, and this is how we are going to produce the graph. And this may not be the best looking graph, but its equation here is y is equal to x square plus 4x plus 6. And as you can see, this doesn't intersect x-axis at all. However, it intersects y-axis at the point 0, 6. So 1, 2, 3, 4, 5, and 6. This is the point y-intercept, that is 0, 6. That's it for now about quadratic functions. We will do a couple of more lessons regarding using technology to graph and estimate quadratic functions from the given data, but that will come a little later.